SOLIDWORKS Simulation is a powerful and accurate stress analysis tool built right inside the SOLIDWORKS design environment. It allows you to do virtual performance testing of your parts and assemblies, allowing you to determine if the product is strong enough to meet design and abuse conditions it will see during its lifetime. This allows engineers and designers to greatly reduce the amount of product testing and prototyping needed before product release, saving significant time and cost. SOLIDWORKS Simulation has 3 different bundled packages, but the starting point for most projects is linear static stress analysis. This allows you to subject your virtual model to one or more design loads and see how it will deform and how close to failure it will get. The analysis process in SOLIDWORKS is simple. We work right within the same design environment as our 3D geometry, so we never have to import or export models into our analysis environment in order to do testing. We advise the software some information about the materials we're working with for these parts. We tell the software how the object is restrained against the environment, and we specify the location and value of any loads being defined. Here we have 6,000 newtons of force being applied to the central ball. This example is from a steering bracket on a vehicle, and that applied load represents an extreme steering event. As this is an assembly, we identify relationships between the individual parts in the assembly, whether they're bonded together or whether they're free to slide against each other and separate. We want to get that contact as realistic as possible. Once all these user-defined inputs are in place, we ask the software to mesh the situation. We can either rely on intelligent automatic settings or adjust as we see fit, and then we go ahead and solve the analysis. Once complete, we can explore information about the stress levels throughout the model, how much it is likely to deform under this loading, and even look at the factor of safety, comparing the stress developed in the model to the yield stress of the individual components. In this particular example, our design limit is 150 megapascals, so we're well under that limit as a peak stress, and there's a huge range of other graphical and numerical data in a variety of unit systems, so you can work with whatever you're comfortable with, and we can explore all of that. However, the real power of SOLIDWORKS Simulation is the ability it gives us to explore variations to this model. Because I'm still inside the SOLIDWORKS design environment, I can easily change the design, such as this dimension here. As soon as that adjustment is made, I get flags in my analysis examples telling me that something has changed, but in order to process that change, it's as simple as telling the software to run. It will mesh and analyze that new geometry, and I can instantly see the effect of that change on the stress and deformation results. The SOLIDWORKS Simulation Standard package includes both linear static stress analysis, as we've done here, and fatigue. So while this current analysis tells us if the product will fail when this load is applied one time, a fatigue analysis helps us predict how many loading cycles this object can experience before experiencing a fatigue failure. We define some fatigue testing information for the materials being used in the form of an SN curve. We provide some information about the nature of the repeating event. And then when we go ahead and process a fatigue analysis, we get predictions of product life. How many cycles will it endure before it experiences a fatigue failure? And this we can compare against our design goals. In summary, SOLIDWORKS Simulation provides integrated, easy-to-use analysis software that enables designers and engineers to get accurate predictions of product performance and explore an infinite number of variations to their designs as quickly and as effectively as possible.